Hey everyone, and welcome back. Before you watch this walkthrough, make sure that you pause the video and try the problem yourself. Even a partial attempt will make the explanation that much more useful. These videos are meant to support your problem-solving process, not replace it. Across a lot of my practice problems, I highlight different aspects of how to approach, break down, and reason through problems. So you're going to get the best benefit by watching multiple walkthroughs rather than treating any single one of my videos as a template that you can copy. With that, let's get started. This practice problem is going to build directly on our previous problem of inserting into a sorted list, where now we're going to do a delete value. We're building on that insert value video solution, so watch the previous video if you want to see how I got to my current template code. And what we're going to do is we're going to remove the first occurrence of a value from a singly linked list. Here we can see we have a singly linked list, 1, 4, 5, 7. And if we go and try to delete the value 5, our output should now be 1, 4, 7. This operation is the mirror image of an insert. Instead of wiring a new node in, we're going to skip a node and reconnect our references around it. Our traversal pattern stays the same. And there are two main cases here. Either we're deleting from the head, or we're deleting a node in the middle or the end of our list. Let's do as we always do and write the logic in our comments first. I have all my code from my previous solution that I'm going to leave there, and we'll go ahead and just write around it. Delete value, and the value we want to delete will be passed in. Now, of course, if our list is empty, there is nothing to do. If list is empty, do nothing. Else, what is it that we need to do? We need to walk our list until we find the node that matches our value. Walk through list, looking for matching value to data. And then once we find it, we need to rewrite, I guess both work. Rewire our node references around the target value so that it is deleted. There we go. That's really all there is to it. This rewire, of course, is a couple of steps, but it's pretty straightforward. So I will turn this into code. We understand that if our top is null, our list must be empty. And we said if top is null, do nothing. Else, let's go over here. Now, if you've been following along with me over the last many videos, you'll know that I hate this. I hate a method or an empty conditional like this. If this is true, do nothing. Or if this is true, do a return on a void. I absolutely hate that. The simplest way around this is just to flip our if statement. And now everything works just fine by removing the else. So now, if our list is not empty, let's go ahead and fill in this logic. Now, like we said, we have two cases. If the data that we need to remove is our head, we have a very special case here. So if, since we know top is not null, this .top.data is the same as our data, we need to remove the head. And very simple, this .top just needs to be equal to the next node in line. And now we've pulled that in front reference off and we're totally good to go. If this isn't the case, we instead need to traverse through our list to find the node. And we need to find the node before the one that we want to delete. Similar to our ordered insert where we had to find the node before the one where our new node needed to live, just because of how that rewiring is going to work. So let's start as we always do with making that temporary variable. Node cur is equal to our top node. And then we can go ahead and do our looping. While our current.next does not equal null, as we had before. And what's our other condition here? Well, rather than in our previous one where we said it was less than the next one's data, we want to say that the current.next data does not equal our data that we're looking for. That's really our check here. So this is us walking through. Of course, we have to actually do the walking. So let me fill in cur is equal to cur.next. Now we're walking through. After this loop ends, there are only two possibilities. Either we're at the end of the list or we found the node to delete. If cur.next is not null, it means that we found the node we need to delete. So we can do a check for that. If our current.next, does not equal null, we can rewire around the node that we need to delete. I wrote current, but I meant cur. So now our cur next no longer should be the node that is there, but instead should be the next one's node. This line's a wild one to read, but that's exactly what it is. And then once we're done, we've rewired around the node we wish to delete. Let's go ahead and look at our code here by doing a delete. What did I call it? DeleteValue. Let's start by deleting 5 and printing out our list. So we'll compile, no errors, that's a first for me, and then we can run it. And what we see is that we do take our initial list after adding everything in sorted, and then we do our deletion from our list. We do a delete value. This doesn't have to be done on a sorted list, by the way. It can be done on any list because we're just doing a linear search through our list to find our deleted value. When we found it, we rewired the 4 around 5 all the way over to 7. Let's make sure that this works for other values. For example, can we delete our last element? Delete value 7. No problem. Can we delete our first element? Linked list dot delete value 1. Once again, no problem. And finally, what happens if we try to delete a value that doesn't exist? We can see that our data remains unchanged. Nothing happened because we tried to delete something that wasn't actually ever in our list. Play around with this, draw lots of pictures, and get in lots of practice. You'll be able to solve problems like this in no time. That's it, and now we've solved this problem. Now remember, you won't find my solution posted alongside this video. If you watch the walkthrough without first attempting the problem, stop here, close my solution, and try to write it yourself now. Post-walkthrough practice still counts. If you have questions about this problem or suggestions for future practice videos, please be sure to leave them in the comment section below. Thanks everyone, and I'll see you next time. Bye.